Hello everyone, welcome to my channel again. I'm Karthik and today we'll be creating a vellum cloth simulation. Something like this. You must be seeing it on your screen right now. So this is what we are going to create and let's begin. We'll start with a geometry network. Let's call it sim. You can name it whatever you want. Let's color it. Let's dive inside and create a grid. This will work as our cloth. I want this grid to face the x direction, something like this, the positive x direction, and increase the rows and columns to 100 by 100. I'll decrease the size as well. This is a bit too much for me. 1.5 by 1.5, or let's make it 1.6 and 1.4, so a bit like rectangle. So yeah, after this we'll use a remesh node and decrease the target size here to 0.01, and we'll get our triangulated geometry. So this is something that we'll be using as our base cloth, and now we will use a font node to create points in our groups that we'll be using as pinpoints in our simulation. So let's use a font node. You can use any font here. I'll template this and see this one. I want the K to face the X direction as well. Come to the rotation here, 90, and this is fine now. After this we'll be using a poly extrude node and increase the distance to 0.7. yeah, this is nice. 0.7. An important thing is come to output geometry and groups and click on this output back. This will create a back here, otherwise this will be an open end. We do not want that. And the geometry of the grid and the font are not, why does this keep happening? The geometry and the font are not intersecting, and we don't want that. So what we are going to do is come to the font and move the position, move it a bit in the negative x direction, or so in the negative x direction, so both of them are intersecting. And now we'll be using a group node to create some groups in this grid with the help of that K that we selected. It is important that the group type is points for this to work. Let's name the group pin. This is fine. So this is our group, and now what we are going to do is we'll use a group expand node. We'll name the group name expand. This is okay. We'll use the base group pin, and we'll decrease the steps to -1. So what is happening now is this is our main pin group, and we are decreasing it to 2 steps. So we are decreasing some of the points from the edges here. So that's what it is. Now use a transform node and apply this specific transform to group expand 1 and translate in the positive x direction. Just make it 0.04, so that K is bulging out from that grid geometry. And after this we'll use we will be using a smooth node to smooth that geo. Now look, this is looking nice, and let's come here and we'll use a group combine to further adjust our pinpoints. So let's name of a new group that we'll be creating as new pin. New pin is the name of the group that we'll be creating, and this group is going to be equal to pin subtracted with group expand. So this is our new pin group that we'll be using as static objects in our Vellum simulation. What we are doing here is we are creating a new group called new pin, and that group is equal to pin minus the group expand. So this is the pin group. This is the expanded version that we reduced to 2 steps, and when we subtract both of them, we are getting our new group, new pin. Now let's move ahead and use Vellum Cloth configure node, and come to the pin to animation, pinpoints, and we'll use our new group, new pin. And let's use Vellum solver. And this was already on the frame 42, so I think we can let it run. Okay, so this is what we are getting when we run the simulation, and it is simply because we have our gravitational force on in the Vellum solver. Come to the Vellum solver, forces, and turn off the gravity, and now when we run our simulation, nothing is happening because there's no force here. So we'll create our own forces. Let's dive into the Vellum solver. Pop wind, we'll use pop wind this time, and let's increase the amplitude to 1.5. That is okay. What I want is this wind to flow in the negative x direction, in this direction, from here to here, in the negative x direction. So I'll come here and I'll give it a direction of minus 0.4. So 0.4 would be in the positive direction, positive x direction, minus 4 would flow in the negative x direction. This is what I wanted, and I'll give some basic direction in the y, positive y, and some very basic, very low in the z direction as well. Now when we run it, let's see what happens. Okay, so as expected, the cloth is flowing in the negative x direction, but this is behaving like a plastic sheet, and I do not want it. I want it to behave like a cloth. So let's come to the Vellum cloth configure node here, and what we will be doing is that we'll decreasing the stiffness in the stretch. So come to the stretch section, stretch stiffness, and we'll decrease it to around 1000. This will be too low, so let's make it 10,000. Let's see how it works. Another important thing that we'll be doing is we will be increasing the rest length scale here. So I'll increase it to 1.15, and I'll tell you what it is. When the rest length scale is 1, that means When the wrestling scale is 1, that means the distance between these 2 points or any of the 2 points in this grid is going to be same. It's going to remain same that we provided. Like this is our geometry, and the initial state or initial distance between these 2 points is this, and wrestling scale represents that. This is going to be the same. When we increase that less-strength scale, when we run the simulation, the distance between these 2 points is going to increase, and in turn the size of our whole cloth is going to increase. You'll see what I mean by that. So we'll increase the wrestling scale by 1.15 and come to the bend section as well, and we will be decreasing the bend stiffness as well, and 1.1 e minus 7. So this is the setting that I am using right now. You can copy it, and let's see what happens now, and you will be able to see what I meant by decreasing the wrestling scale. So see, our simulation is running, and what I meant by this is our initial geometry that we provided, and when we run the simulation, the cloth increases, the size of the cloth increases. It is happening because we have increased the distance between the 2 points here with this wrestling scale. We have increased it to 1.15, and when we run the simulation, this is our base geometry that we provided, initial geometry, and when we run the simulation, the distance between the points increases, and this is how it is behaving now. It is behaving more like cloth now, like I wanted. The only thing now is that the whole cloth is moving in the negative x direction as we set the settings here in the wind velocity. What I want is, I want the whole cloth, this part of the cloth, I want this part of the cloth to flow in the negative x direction, but I want this part, the K section, the K geometry, to flow in the positive x direction. So I want these geometries to flow in the negative opposite directions. So what I'm going to do is I'll use another pop wind, and this time we'll be running this pop wind only on our pin group. So what was our pin group? I'll remind you again. This was our pin group. This K, whole K, was our pin group. So that is what I am running our simulation on now, our pop wind on. So this pop wind will affect only this part of the geometry, and I want this wind to go in the positive x direction. So we'll use 2 here. I'll increase this amplitude to 2 as well. So let's see what happens now. Okay, perfect. You can see that the whole cloth is moving in the negative x direction except this one. This is flapping or floating in the positive x direction. I'll add one more thing here, a pop drag node, which will create some form of air resistance here, and now I'll run the simulation. Okay, so this is running fine. This looks nice, and the only thing that I'm going to do now is I'll use a Vellum post process node, and The subdivision is set to none. I'll choose the loops. This way we'll be increasing the number of points here, and it will look better. You can also increase the smoothness if you want. And you can see this is how your cloth simulation is looking. You can use any letter or any word even with this method. You can choose anything, you can write anything here, and this setup will work perfectly fine. So I'll just use the null out, and this was our simulation. You can run it and you can cache it as well if you want to render it. Now I'll show you the lighting setup and material setup. Okay, so before the lighting, I'll just add a background node, background grid. So this is too big. I'll decrease the size to 3 by 3, and I'll position it here. You can select, you can choose an angle that you like and just click on camera with control. So this will give you this will set a camera for you. Now we'll use the redshift lights. I'm using an area light. I'll make this first light for the front top. I can increase and decrease the intensity here. So we'll decrease the size. Make it a rectangle. And I'll make it a normalize intensity, and also let's decrease the spread. The intensity 100 is too high, I know that, and because the intensity of 100 has never worked for me, so I'll just decrease it. I'll make it quite low because I'm working with a small scale simulation here, so 4 will be fine. I'll copy this light and adjust the parameters. I'll decrease the length here and position it. I'll position it here on the side. Also, I'll decrease the intensity to 3. And we'll need one more light. So both of these lights will be only affecting our sim. So come to the light, come to objects, and we can select what part of our whole geometry we want this light to be this light to affect. So I want this light to affect only the sim, and this light also the sim, and I copied this third light here, and this light I want for the background. Adjust the position. Increase the intensity to around 20. For this background light, let's apply it only on the background grid, so this light will not affect our simulation. And let's see how this is going to work, but first we will have to set the redshift IP here. So come to the redshift tab and click on redshift. This will create redshift ROP and redshift IP here. So come to redshift ROP, click this and play. This is just my regular setting that I'm showing you. I'll turn this to 120 because this is testing. I'm testing this render, and that is it. I'll set the materials later. Let's just run it now and see what is happening. Okay, so this is looking decent. Now we will apply our make our materials and apply it to the geometry. Before we make our materials, one thing I forgot to do was set UVs for our grid, and you can do it very simply with the help of a UV project node. Now we have applied UVs on our grid, and now you can run the simulation and this will work perfectly fine. Now select a frame that works for you, and now we'll create our redshift materials. Come to the material section here, and I'll choose a redshift material builder. Let's call it sim. I'll go inside, and instead of the standard material, we are going to use a redshift material, RS material. And here we are going to use a preset called, here in the redshift material, RS material, we are going to use a preset called plastic. So this is it. Increase the roughness to 0.6. I'll increase the roughness to 0.6 and I'll change the Fresnel type to metalness and increase the metalness here a bit. Around 1.65 is okay. I'll also make it gray, the reflectivity. Let's choose this one. So 0.75, 0.75, 0.75 is the standard. So after this, what I'm going to use is a RS ramp, and I'll connect this RS ramp to the diffuse color. And what I'm going to do now is I'll set 3 colors on this ramp, and these 3 colors will be applied as a gradient to this cloth simulation. So the first color that I'm using is pink. The final color that I choose is going to be cyan, and in the middle I'll choose blue. I'll make it less contrasty. So let's see So come to the object section, object network, and will apply our material to our sim geometry. Come to the render, apply the material, and let's render now and see what happens. So this is the render, and you can play with colors here. We can curve. So this is looking nice now, and you can make your own changes. You can change the lighting, or you can change the background color, or you can change your own colors. And so this was the video, guys. I hope you guys enjoyed it. You can render the full animation if you want, and let me know what you guys think of this video. If you have any suggestions, you can drop them in the comment section, and project files will be available on my Patreon, so the links are in description. You can also hit me up on Instagram. All the updates for the future videos, the upcoming videos will be there. And for the next video, we'll be creating another vellum cloth simulation. So if you would like to see how I create that, you can subscribe to the channel, and I'll see you in the next video. Thank you. Bye.